Okay, so what is it? 521, right? 521. So today we're going to talk about inscribed angles. Okay, so inscribed angle, right? So to be an inscribed angle, it's an angle with its vertex on the circle, okay? So an inscribed angle is an angle with its vertex on the circle, okay? Let me draw a picture. So the last few days we've been dealing with what we call central angles, okay? That's a central angle because it's at the center, okay? That's a central angle. And what we've learned about central angles is they basically equal their arc. So if that was, say, 80 degrees, its arc is 80 degrees. So we've learned that, right? Central angles are angles at the center, and the angle is equal to the arc length, okay? Now, inscribed angles are different. So if I take a look at this angle, angle D here, right? That's an inscribed angle because it's right on the circle. So we can describe it in two ways, either angle D or we can call it angle ADB. Angle D or angle ADB. Same angle, angle D or angle ADB, same angle, is equal to 1/2 of its arc. Half of arc AB. So it's half of its arc. Inscribed angles have taken the angle here, and when you pull it back, it gets skinnier. Can you visualize that? If I take this angle here and pull it back, it would get skinnier, wouldn't it?
Yeah.
Can you visualize that?
I think I can.
You can kind of see it, how if I pull this one back there, it gets skinnier. So it becomes half as big. So then if I say an example, let's say I say this angle is, say the arc is 160, then the angle is 80, okay? It's just half its arc. So whatever this arc length is, an inscribed angle is just half as big. Easy, right? Easy. Okay, now number 2. Can I go on? So it's half its arc. There you go. Half its arc. So let me go up to number 2. So when I look at number 2, and it calls it the right angle theorem. There's a reason it's right angle theorem, because if this is half a circle, right? How many degrees is half a circle?
180.
So that would force that to be 90, which makes it a right angle. Yeah. Well, not necessarily 45. We're not sure on that. But I am sure of this. So if that's a diameter, so if AC is a diameter, right? That would make arc AC 180 degrees, correct? Because it's half a circle, right? So I know that this arc has got to be 180 degrees because it's a semicircle, right? So that would make angle B would have to be 90 because it's half of it, right? So the measure of angle ABC has got to equal 90 degrees because it's 1/2 of its arc. Yeah, R2?
So basically, because that triangle is in a circle and line degrees, that automatically makes it half.
Half of your arc. So what's the arc? So let's go back and say it another way. What's this arc? It's half circle. What's the arc?
Oh, I see the arc. I see where it is.
And it has to be half of your arc, right? Now, Derek, we don't know what A and C are particularly, but we do know together they add up to 90, right? Does that make sense?
Oh,
I mean, they could be 40-50, they could be 60-30, but together they make 90, right?
Yeah.
Okay. All right, now finally, last one. So if you get a quadrilateral, okay, and there's 360 degrees in a quadrilateral, we're going to say that the opposite angles are supplementary. Okay, so what does that mean? It means that they add up to 180 degrees. So I'm going to say angle, you ready? angle F plus angle D equals 180. Supplementary. Opposite angles add up to 180 degrees. So D plus F, they're not equal. They're not equal. D plus F, they're not equal, but they add up to 180. And we could say also that angle E plus angle G also add up to 180 degrees, okay? They're not equal. They're not equal, but they add up to 180. So all these very unique things happen because of a circle, okay? Pretty cool. Thumbs up? So let's turn the page and look at some problems, okay?
One second.
Yes. There you go. Go ahead and write that down, okay? So supplementary means they add up to 180, right?
Okay.
Okay, turn the page. All right, so example 1, A and B. So find the missing angles and arcs. So I don't have a lot, but what I can do, Hayden, if you stop talking, I'm sure I could do a lot, is before I do anything, what I probably ought to do is find this arc. How many degrees in a full circle?
360.
So let's find out. Let's go 360. We'll subtract 120, and we'll subtract 70, and let's see how many degrees I have left, okay? All right. So clear 360 minus 120 minus 70, and I get an answer of about 170. So let's put 170 right here. This is 170. Okay. Now I'm going to be able to find angle G. So the measure of angle G. G is an inscribed angle. G is an inscribed angle. It's going to equal half its arc. G is an inscribed angle. It's going to equal half its arc. Is equal to 1/2 of 170 degrees. So 170 divided by 2, I get an answer of 85. So the measure of angle G has to be 85 degrees. Okay, does that make sense? It's just half of its arc. I had to find its arc first from 360. I had to find its arc first from 360. Then, once I found its arc, angle G is half of that. Okay? All right, B. All right, well, let's do this the other way. If angle R is 40, then, now I'm going to highlight it, then this arc PS has to be twice as big. It's got to be 80, right? So the arc's 80, right? And, yeah, exactly. So Derek's ahead of me. If this is 45, then this arc here has to be double that. So this is 90. And we don't really know enough to get the others, but we know enough to get those two, okay? Thumbs up? Does it seem pretty easy?
Pretty easy.
Okay, example 2A. All right, easy question. Let's get the easy stuff first. Okay, highlight it. How many degrees is this arc? Is arc XC? How many degrees is XC? See it? How many degrees is XC?
Half.
180. Half a circle? 180. You guys okay with that? 180?
Yep.
So that means that my 3x is equal to half of that. So 3x is equal to half my 180,
90.
which is 90, right? You guys agree with that? Which is 90. Okay, so then my 3x is equal to 90 divided by 3.
30.
X is equal to 30, right? Okay, awesome. We got x. Okay. Now, if I take a look at the fact that that's 90, right? This angle here is 34, right? So if that angle is 34, then this arc here is 68. Okay, twice that, right? So if that's 68, that's 34. Okay, now, yeah, I know 2y then. I know if this is 34, right? Then the 2y, well, let's see, what's 90 minus 34? 90 minus 34 is 56. So this angle here has to be 56 degrees. So then my 2y is equal to my 56. Okay, these two angles have to add up to 90, right? That was 34. Okay. So if I subtract 90 from 34, this angle's 56. So I've got 2y is equal to 56. divide by 2, divide by 2. 56 divided by 2 is 28. So y is equal to 28. Okay, the last thing I can find, I really can find this arc here. If I wanted to find, let me use a different color. Okay, can you guys see yellow or not? Can you see the yellow? Is the yellow showing up? Kind of, sort of. Here, let me use my other yellow. Okay, here's my other yellow. Can you see that? Is that better? Okay, so if I want to find arc xy, I'll just go 180 minus my 68, because that arc's 68, right? And I get an answer of about 112. Okay? How's that? How am I doing? Thumbs up?
Wait.
Yeah.
So, back a few steps, X. How did you get 68?
Great question. So, do you see the triangle here?
Uh-huh.
Let me highlight this triangle so you can see it, okay? Let me make it I'm going to make my triangle good and dark for you, okay? Here's my triangle, okay? Artem, you see my triangle?
Yeah, I see the triangle.
Okay? These two angles have to make 90.
Wait, but it hasn't curved enough, so is this an estimate of it?
No, if that's a diameter, right?
I know, but the outside thing is actually curved.
It's not actually an angle.
It's not actually 90.
No, just look at the purple triangle only.
I know.
Yeah, but it
This is 68 is the arc, right? But the angle's 34.
Oh, 34.
Right. So you ready? 34 degrees here. These two angles have to add up to 90. So I just subtract 90 from 34 to get my 68.
So you're saying
Oh,
the three,
okay. I see where you got that
3x or
from.
Yeah.
The 3y. Oh, I see.
Equals
It
56.
actually has a little, it's not curved.
Yeah, equals 56, yeah.
I thought you were going on the outside.
No. Yeah, I see
So I
what
was
you
like, that wouldn't mess with the...
Right. Okay, last but not least, okay? Let's do the last one, okay? So this is a little hard because I'm not sure what's going on, but let's see if I do a little bit of math. So first of all, how many degrees in a circle, right? I want to find this arc first. The first thing I'm going to do is I want to find arc JK. Okay, before I do anything, I want to find that arc, okay? So let's go 360 minus 54 minus 110 minus 130. Did you get 66? Okay, so I'm going to believe him. Okay, so Max says 66 is what he says. Okay, now, watch me draw this carefully. We've got to find B and we've got to find A, okay? Watch me draw it, okay? So, see how I'm going to draw it in purple? All right, can you guys see that in purple? And let me go ahead and draw this angle here. So 4B is equal to half this whole arc. Okay? 4B is equal to half of my 110, 176, right? Okay? So 4B is equal to half of the full arc because it touches there and touches there. So it's full arc of 76, so 4B is equal to half of 176. I don't know. 2, 88. Okay? Divide by 4. Divide by 4. B is 22. Okay, now let's figure out what A is. See if I can use a different color, okay? All right, let's see. Here is, you guys see my highlight there? See my highlight there? Let me go ahead and scratch that in, okay? So here's 3A, right? See my 3A? So my 3A goes from K to M, right? So I'm going to say my 3A is equal to 1/2. Oh, what's 66 plus 54 is 110? Oh, 66 plus 54, 120. Okay, so you ready? These two make 120 degrees. So 3A is equal to half of its full arc. Its full arc is 120. So 3A is equal to half 120, or half of 60. Divide by 3. And A is 20. You have to. We already did the germ, okay? Not bad? Not bad? Okay, that's all I have. Okay, so today